Hey everyone, welcome to the Unhandled Exception podcast. I'm Dan Clark, and this is episode number 60. And today I am really excited to be joined by Scott Hunter to chat about .NET Conf and the release of .NET 8, which, when this episode drops, should literally just have happened. But right now, at the time of recording, we're still a couple of weeks away. So a massive welcome to the show, Scott.
Thanks for having me back, Dan. I can't believe it's been as long as you said it was. It feels... We were just talking earlier about the tech industry moves at this crazy pace, and which makes our jobs fun because we're always exploring new tech and there's always a new thing. Like if you told me last time we chatted that we would be talking about AI, the next time we chatted, I would be like, no, we'll not be talking about AI, but the AI revolution's happened. And so, we'll have to talk about that a little bit today as well.
Yeah, I think it was last May for the Build conference that we last spoke, and I think there was you and Gareth Seth who joined me on the show.
Yes, it was.
And yeah, that, as you say, it feels like a very long time ago.
It feels like a long time ago. I mean, as I said, the tech industry moves so fast, and .NET moves so fast too. I'm super excited about a lot. There's a couple of big things in .NET 8 that I'm really excited about. One is we've been doing a lot of work in the company around AI. Obviously, we have Azure OpenAI. OpenAI being the technology that powers ChatGPT, but that technology is based on what we call large language models, and a large language model is what allows us to make queries to the technology in English. To me, that's the revolution. Before you and I have actually just searched for stuff, in a search engine. You type something, you don't get what you want, you just rephrase it, and you keep typing it again and again. And I can't wait to say, imagine I can go to Outlook one day and I can say, hey, Outlook, when was the last time that I spoke to Dan Clark? And it goes, oh, it was last May. That day is going to happen. And being, it's amazing when you can ask the question just like that. I can go to the tech and say, hey, I was talking to Scott Hanselman 6 weeks ago about doing a podcast. And, Outlook would go find that for me. That is going to be, a huge advancement. And the LLMs, the large language models, just primarily enable you to do those types of things. You can speak to the computer in English, and we're doing a lot of work in .NET to make sure .NET customers can have that experience in .NET. And I would love to talk a little bit about that today. Another big area that we've been doing a lot of focus on is AOT, ahead of time compile, and that's primarily because the platform and language market is always changing. Our primary competitors today would be things like Python, Node.js, and Java. But there's some new languages coming on the market like Go and Rust, which are very good at doing what I would call ahead of time. And we should talk about that a little bit as well. And then finally, I want to close out with other platforms like Java have frameworks called Spring. That's kind of their cloud native framework. If you're building cloud native applications in Java, you're likely using Spring to do that. And at .NET Conf, we announced .NET Aspire, which is the .NET framework for building cloud-native applications. And so those are the three areas that I would love to talk through and talk about today.
Yeah, I would definitely love to talk about Aspire as well. Also, I guess we might struggle for time, but there's other things like, I know there's the VS Code C# Dev Kit, which is quite interesting, and then C# 12 and Blazor as well. That sounds like a huge kind of thing, but I'm aware we're kind of really pushed for time. One thing you did mention about the AI stuff, and I saw in the agenda, and you also mentioned Scott Hanselman, coincidentally enough, that he was doing a talk on something called semantic kernel, like an open source.
Yes, and I can explain semantic kernel and why that's interesting, especially to a .NET developer. So let's start with C# 12. C# 12 is got a couple of features that really are exciting to me. We've been on this journey the last couple of years to really try to simplify our language. And what I mean by simplification is, I think it was .NET 6, where we got rid of, if you want to create a new .NET application, you could just start writing code. There was no usings at the top. We were able to put all the usings. We can either infer them, or you can have a global usings where you basically a C# file where you create a list of all the usings that you want, and we'll inject those into every file. So there is no using system at the top of every file anymore. What people don't realize is if you don't write a program class and a main method, we actually generate those for you anyways. So when you start typing, if you go look at the code we generate, we still generate the program class, we generate the main. But that started this whole journey of trying to simplify C#. And the reason we did that, some customers have actually complained about this. They're like, why did you get rid of main and all the usings. And we did that because we want to make sure that .NET is approachable for all developers. And Python and Node.js applications don't have all that boilerplate. And so we want to make sure a Python developer that wants to try out C# doesn't go, wow, this is super complicated. Why is it so complicated? So, but we've added a couple of really cool features. There's two that are my favorite features in C# 12. And one of these is going to be called primary constructors. And so what a primary constructor is today, and my favorite example of this is a ASP.NET Razor Page application. So if you build an ASP.NET Razor Page application and you open up the C# file, the CSHTML file, or the Razor file, what you're going to find inside of that is there's a constructor for your class. And because we use dependency injection in ASP.NET, it's going to have a constructor that takes a iLogger, and then it's going to have a variable in the class. And all the constructor is going to do is assign the iLogger passed in to that variable. And we do this all the time in .NET. You create the private instance of the logger. You got the constructor that takes the logger and it assigns the logger to the private instance of the logger so you can use it in the rest of the methods in the method body. So a primary constructor changes that, where you actually put the constructor directly on the class. And so now I could say, class my page, and I put an iLogger space logger. And what happens is we automatically create the private instance for you, and we do the assignment for you. So basically, you write no more code. It gets rid of the member variable, and it gets rid of the constructor that assigns the member variable, the passed in thing to the member variable. So it basically removes 6 lines of code for every single page. How many times have you done a class where you do like a prop of int x and a prop of int y, and all your constructor does is say x equals x, y equals y?
All the time. That's
all
why
the time.
I heavily rely on the IDE to actually inject that and all that stuff, but that'd be so nice. So is that almost like we've got record types, but where a record type creates a property, this is creating a private field if it's a class?
It's doing the same things, and it's doing the assignments for you as well.
Nice, very nice.
And so it's just removing boilerplate. The second one that I find really, really cool that we're doing is what we call collection literals. And how many times have you done a collection and you do new collection of blah, 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 blah? If you're doing like an array of int, you just say square bracket, int foo, and then you say equals, and you just give it a list of values. If you create a collection of int, well, then you do a new collection event, and we got rid of all the new collection event. We can actually infer that. So now you can do a collection event and just pass us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we can automatically infer that new collection event for you. You don't have to do that anymore. So it's once again just a reduction of text. I wish this was a video thing so we could actually show the video. But those are my two favorite features in C# 12. There's other ones. You can do an alias of a type. So you can make, like I can make a new type called Scott, which maps to int32.
Yeah, I know with the documentation for the alias, one example it gives is tuples, which that is, for me, that's a really, really good use case because I use tuples all the time, but quite often I want to use the same one in multiple places in the file, and that's just seems perfect.
My demo of that is I actually create a point tuple, and then I call the point tuple point, and then I can use point anywhere in the application, and it just works. And so agree 100%. That's one of my faves.
Yeah, definitely. I think also with the collection expressions, I think that supports something called the spread operator, which if you're coming from like the JavaScript land, it's kind of, and also like if I'm jumping between JavaScript and doing .NET and stuff, quite often, because in JavaScript you don't need to put the new for an initializer, right, which you don't need to with this collection expression. At the moment, I would go to .NET and not add the new, wouldn't compile, and it's like, oh, I forgot the new. Where this feels, and with the spread operator, it feels like it's really, I don't know, cleaning things up.
Exactly. That's exactly what it is. There's a crazier syntax there as well, and that's why I think the collection initializer is super cool. Is it just once again, all this boilerplate that you do every time. It's like list of int c equals new list of int 1, 2, 3, 4, 5 is now just list of int c equals 1, 2, 3, 4, 5. And there's a cool website called C# Lab. I don't know if you ever played with that. It's a website you can actually paste the C# into, And you can paste both versions of that into this thing, and it'll show you what the compiler generates. We generate the exact same code. All we're doing is now we can infer the new list of int or new list of string or new list of whatever. And there's a crazy one too. If you have a couple of lists, there's a new syntax where I could do a list of int foobar, and I could say dot dot list one, comma dot dot list three, comma dot dot list two, and we'll take the data from each of those lists and put them into the initialization for you. So you can basically do crazy things. I do like reverse strings by doing this kind of stuff. So that's more exotic. But as I said, I think the primary constructors and the collection literals are going to be the most popular, new features for most of us. There's default lambda parameters. There's inline arrays. There's field access and auto properties. There's the aliases you and I talked about. But I think the ones you're going to see the most are going to be the primary constructors and the literals.
I'm nervous about saying this other feature because it could become an entire episode, I guess, but interceptors as well.
That is an entire podcast by itself. I purposely left that one off because that's a rabbit hole. That's a very deep rabbit hole to go into. If you want, I'm happy to introduce you to Mads, and I would have Mads come on and do a podcast with you and just do a deep dive on interceptors.
That sounds awesome. Yeah, definitely.
And for folks that don't know, Mads Torgerson is kind of the primary driver of C#. So after Anders Hallberg moved away a little bit, Mads is the one who's been driving C# for the last quite a long time, since just basically C# 3.5-ish.
I have a feeling that most of our listeners would have heard of Mads.
I would hope so.
We're going to pause the conversation just for a moment for a quick mention from our amazing sponsor, Track.js, who are helping support the show. We have lots of great tools to observe what happens in our backend services, but what about the client side? We've packed a lot of functionality into our web apps, and it's going to break sometimes. Track.js gives you fast and easy visibility into what's happening in your web applications, collecting errors and events with powerful heuristics and filtering rules to find issues that actually matter. So go check it out at trackjs.com. So moving on from C#, I'm quite excited because I actually don't know that much about it, but I've heard of it, but this .NET Aspire, and obviously this is like secret at the moment, but by the time this podcast comes out, it won't be.
Yeah. So let's talk about Aspire. We did a project 3 years ago. It was an experiment. It was called Project Tie. And the main things that we were trying to solve in Project Tie were .NET is, I would tell somebody, you can build amazing cloud-native applications in .NET. We've done a lot of work in ASP.NET, in the core runtime, in the BCL, and the tools to make .NET a great framework or platform for building, cloud-native applications. But today, you have to know how to turn all the right switches on. And I'll give you an example. If I'm in the cloud, I really should have a HTTP client factory. And in that factory, I should initialize the defaults for my HTTP client so it has resilience on by default. And what resilience means is if I'm on my own machine, I can make a call to an API on my own machine, and it's going to be very fast every time. When I'm in the public cloud, well, maybe just because of a wobble in a data center, the call is like 3 milliseconds every single time, and then suddenly it's 3 seconds. Well, most of our apps would crash on the 3-second delay, but with resiliency turned on, the technology will auto retry that a couple of times before it actually fails. And this makes the app resilient. So if you knew that we had that feature and you turned it on, well, good. Aspire is a cloud-native framework that will turn that on for you automatically. NVIDIA Framework Core, same kind of thing. We have a feature in NVIDIA Framework Core which you can turn on retries, meaning that I make a call to the database. Maybe the database doesn't respond right away. Most apps would just crash right there with an exception and blow up. But you can set a retry policy saying, hey, if the call doesn't return right away, pause for half a second and try again. And so .NET's full of all these little gems of features that you should be running by default if you're building a cloud-native application, but we don't turn them on by default. So one of the goals of Aspire is it's going to turn on all the best practices by default. I'll give you another example of something is when we rebuilt ASP.NET Core back in 2016, one of the things we had learned from MVC and ASP.NET Web Forms was we didn't put good logging into the system. And so Aspire is going to turn all the best logging on by default. And by the way, even in current ASP.NET Core, it's there, but we don't turn it all on. And so we want to turn all the logging stuff on, the best practices for logging, they're on by default. So we're going in what I would call being opinionated. We're taking all the best capabilities and turning them on. But the biggest thing, and I've done this before and I've struggled with demos before, is okay, I'm going to build a multi-part project. I'm going to have a Blazor front end and I'm going to have an ASP.NET Web API back end. Well, if you're in Visual Studio on a Windows machine, how do you start that? Oh yeah, I right click on Solution Explorer and I say I want to do a multi-project startup. Most of our developers know that? Nope. If you're in VS Code, what do you do? Well, okay, you can go into the folder of the first app and do .NET Run, the folder of the second app and do .NET Run. We're not good at running multi-part applications. We never have been. At best, that technology was invented years ago to make a Windows Phone application probably work, where you had a phone and a back-end API. So Aspire brings a new technology called DCP with it, and this is a runner that can run multi-part applications. And this will just be on by default. So once again, you don't have to go and right click and do a bunch of stuff. It's like, hey, I've got a multi-part application. We need to start this application. And so that's a feature of Aspire. So it's got resiliency on by default. It's got logging on by default. It knows how to run a multi-part application because we assume a cloud native app's got a front end and a back end. And so another component of multi-part applications that are hard in .NET would be in that exact scenario I said. You go to in your Solution Explorer, you right click, you add Blazor, you right click, you add Web API. Well, how does the Blazor app get the IP address of the Web API? What you would do today is you would likely go to your Web API project, you open properties, open launch settings, find whatever IP address we generated automatically, you would copy that, you would then move it over to your Blazor project and you would paste it in.
That sounds so familiar.
Now yeah, exactly. We've all done this. I've done this a million times. That sounds great. It works. But then you decide you want to publish that to the cloud. Well, all those IP addresses are going to change. And so that doesn't work. And so that's not good. And so literally we're trying to solve that whole class of problems with .NET Aspire. I'll throw the third scenario out, which is, hey, I want to use a component that's not on my local machine. So for example, I want to run let's say a Postgres database, or might want to run a Redis cache. Well, I have a couple of choices. I could go and find a version of those that runs on my machine. I can install them. As a developer, I hate this. I try to protect my machine and only install the least amount of stuff on it because I don't want to have to rebuild it or worry about something breaking something. And so I assume, Dan, you're the same as me, that I'm very protective of my environment, and I try not to tweak it too much. And so with Aspire, there's also a notion of Aspire components. And there'll be a Aspire component for Redis, there'll be a Aspire component for Postgres and MySQL. And what'll happen is we require Docker for Desktop. If you want to do this type of operation, what we'll do is we'll actually go and download Redis from the container from the container registry, and we'll run that on your local machine. Now, the nice thing is that's a container, which means when I do .NET Run, we'll boot the container up. When I stop the application, the container goes away. There's no Redis on my machine anymore. It never affected anything in my box. And so Aspire is technically a collection of all these types of things sewed together. And so let's talk about how an Aspire app would be different than an app that you have today. So what I would actually do in Aspire is I would typically go do exactly what we just said. I would start off and add a Blazor app to my solution. I would then go add a web API to my solution, and then I would do a new gesture. There's a new gesture in the tool. I can right click and I can do add, and there'll be add Aspire orchestration to my project. And so when I do that, so it's basically add, and I'm doing it on my machine here just to kind of walk through. It's Aspire orchestrator support. And it's going to basically say, I see these two projects in your solution. Which ones do you want to add orchestration to? And so I'm going to click the Blazor application, and I'm going to click the web API. If I only click one, I can come back and run it again and click the other one. So it's something you can do. And what happens when I do that, it's going to add a new app to my solution. And I call this the orchestration app. It's going to add what we call an app host. And the app host is the glue. It's how you say, basically, I want to glue these two applications together. So what I would do inside of my app host is I would say builder.add project and give it the name of my web API. and I assign that to a variable. So I've got my API service as a variable, and then I would do builder, add project, and pass my Blazor app to it. And then I would say dot with a reference to API service. So what I've basically done is I said, hey, I've got two apps as projects, and now I want to glue them together. And so by saying with reference API service, the host is actually what DCP does to start the app up. So it's going to go and say, hey, I see I've got an app, and it depends on the other app, which means it's going to start the API first because it knows that the Blazor app depends on the API. So the Blazor app can't work without the API. So it does that connection first. That tech inside of that app host is how when we start the app up, the runtime engine goes, oh, I see these two apps have to happen. They connect to each other, and I'm going to start them in the correct order for that to work. But even cooler, I didn't say one thing is when I do a builder.add project, I can give each of my projects a name. And so I gave my API project a name of API service, and I gave my Blazor app the name of web front end. Now, why does this matter? This matters because in my Blazor app, when I want to go call the backend, I don't have to go to launch settings and go grab an IP address anymore. I go grab that name, API service, and do HTTP whack whack API service, and we do the mapping for you automatically behind the scenes. This is super important because it means when I run the app locally, it'll use some localhost address. When I move the app to the cloud, we'll do that same mapping to whatever IP address the container app that you have in the cloud has. And so we do all that work for you. It gets even cooler. Maybe I want my Blazor app to do some caching. So I right click and I say add Aspire component. And components are collections of stuff that it's like if I say Redis, the Aspire component for Redis is going to do two things. It's going to go, hey, I need a Redis container to run locally. So it's going to tell the host, go make me a Redis container. It's going to bring the Stack Exchange Redis client in as well. And it's going to provide that same naming mechanism. So I could go back to my app host and I say var cache equals builder.add Redis container. I give it a name of cache. And now if I run the application, it'll make the Redis container. And I'll go to my Blazor application and I'll also say dot with reference cache, because the Blazor app needs that Redis container to run first so it doesn't crash trying to use the cache. And then I can go to my Blazor app and go to a page and basically add the tag helpers and in the page to use a cache.
When you said go to your Blazor application and say use reference cache, is that in this orchestration project, or was that?
No. So the orchestration project think of the orchestration project as it literally is just the app that tells the tool how to start up and gives everything a name and wires it together. My Blazor app, I would just go to, like I normally would, and go to my page in the app and add tech in the page to use the cache. So for example, in the case of like the weather, if I want to use a cache, what I'm going to do is I'm going to go into my Blazor page. I'm going to add an attribute called output cache and set the duration to 5. And what I would have done is I would have gone to my program.cs for my Blazor application. And by the way, we do this for you. By adding that Aspire component, we'll go and put a builder.add Redis output cache instance inside the page. And we'll then go in the app and we'll say app.use output cache. So that component installs those two things into my program.cs that kind of tells the Blazor app, hey, I want to use ASP.NET Core output caching. And once again, because we're doing this naming mechanism, I can just name the cache. If I name the cache my app host cache, inside of my program.cs in my Blazor app, I would reference the cache as cache. So then when I start the project, more magic happens. So when you do all this, when you add that orchestration, that app host becomes the default project. That's the project we want to run. So when you control F5 or F5 in the tool, that's the project we're going to run. And that project is, as I said, is the one that then goes and fires up DCP, which is the engine underneath the covers. And it tells DCP to run, create the Redis cache and run the Redis cache. And it goes and injects environment variables in with all the IP addresses and ports and stuff like that. You don't see that stuff. You don't have to see that stuff. But when you launch the app, you don't launch into the Blazor app. You actually launch into the app host app. And the app host app is really cool because it brings a dashboard up. And this is something we should have done in .NET, ASP.NET 10 years ago. The dashboard's really cool. It brings a web page up with the dashboard. It's going to show all of the applications that you have running. It's going to show your front end and your back end. It's going to have links. If you want to click a link, you can click a link through the backend API, and it'll go and call the backend API. And if you have a default map on your backend, in my case, I do, it returns the weather data. If I click the link on the Blazor app, it just launches the Blazor app. So I can easily launch all of my applications. I can also, for each application, I can say, show me the logs. And so I can actually see the logs of the Redis cache starting up in the container. I can see the logs of the web API booting up and running. I can see the logs of the Blazor app running. And it gets even more interesting after that is we have distributed tracing turned on. As I said, once again, all this tech's been in .NET forever. We just don't turn it all on. Distributed tracing's all turned on. And so what you'll actually see if I go and click the weather page inside of my Blazor app, the first request, you'll see it actually hit the Blazor app. You'll see the Blazor app make the call to the API, and then you'll get the response that you want. If you refresh the page, hit the Blazor app again, but this time you'll see it not actually hit the web API, but you'll see it hit the Redis cache. And so this is all in a distributed log, and it shows you how long each of those segments take. And so you get you get the full output. It's like, how long did it take the Blazor page to load? Well, it took the Blazor page, 15 milliseconds. And it took the API call was 5 milliseconds. And it shows you a graph showing you the whole thing was 20 something milliseconds. The next click through when it does the cache, you'll see that now, it returned in 4 milliseconds because it had to make no calls. And all the way through that, you can click on each of the items that happened. You can see what, if you click on that link on the second one, you'll see that we actually called the Redis cache. You'll see the Redis cache hit. But that's not all. There's one more piece. So, at this point, we've got a multi-part application. We can start it into a dashboard, starting all the components. That can include containers if it requires containers, so you don't have to install stuff in your local machine. We're doing all the port mapping for you. We're doing the component setup for you in a clean way. But the next thing is like, well, I want to publish this thing to the cloud. How would I do that? And historically, what you would do in our tools is you would right-click on the front-end app and say deploy to Azure. You would right-click on the back end and say deploy to Azure. And hopefully you've set the right goop up in the cloud to do all the mappings of the IPs and stuff like that. Well, when you build an Aspire application, we actually generate a manifest. And the manifest is, here's all the components of the app. We've got a web front end that needs to run in a container. We have a web back end that needs to run in a container. And we need a Redis cache. So a tool that my team builds is called the Azure Developer CLI. And the goal of the Azure Developer CLI was if Dan, you had a sample that you put in GitHub, and let's say it required an app service, an Azure SQL database, and a Redis cache, you would have a couple choices. You could, in your GitHub repo, you could have a bunch of instructions saying, go to the portal and create all these things. Or you could say, run a ton of commands from the command line to create all these things. So AZD, which we shipped at build this year, it allows you to put some code in a folder in your application that kind of explains all the pieces. And so I could clone your repo and just say AZD up, and AZD will go and ask me a couple of questions like, what subscription are you using? What data center do you want to be? What region do you want to be in? And automate that entire flow. For an Aspire app, what you do is you run AZD init in the folder of your application. It will then scan the folder, all the code, and it will find that manifest. And from that manifest, it will know enough to put the app in the cloud. And so I've got that, my Blazor app, my Redis cache, my backend. I go and run AZD init. And a couple seconds later, it says, hey, I found a .NET application. What subscription in Azure do you want to use? What data center do you want to be in? And it's going to go, hey, of these containers, which ones do you want to be able to be hit by the public internet? So my Blazor app is the one I want to be able, my API. Nobody needs to be able to call that except me. But I could choose to make it public if I wanted to, but I can make the Blazor app public by default. I'd press return, and then 3 or 4 minutes later, the app's running in the cloud. And so the whole experience I just walked you through, you can do that today without Aspire, and it'll take you 2 hours to get to the point that I just described. But with Aspire, you get there right away in a very easy to use format. I've been playing with this tech for a couple of weeks now, and it's super exciting. And then all that resilience we talked about earlier is on by default. So my HP clients are doing the right thing. My EF cores are doing the right things. And as I said, all that logging is turned on and flowing the right ways in a way that you would never all that logging stuff works today in ASP.NET Core. You just have to go turn it all on. So this is the term I would use, an opinionated cloud native stack for .NET.
I think sometimes that's the best way, really. If there's so many different ways of doing things, that confuses a lot of people. I'm just thinking about the way I currently do stuff. So I use Docker Compose quite a lot locally, which it sounds like that takes away the requirement for that. So quite often Docker Compose is spinning up, like, as you say, Redis or RabbitMQ or SQL Server or something. But then if I'm working with multiple .NET services as well, and more of a microservice architecture, then I kind of want to spin those up as well. I might not be working on those things, but if I'm doing that through Docker, I've got to build a container and everything. But it sounds like this, I can run Docker stuff, but also run .NET stuff that's not in Docker and just orchestrate it all and get a whole bunch more stuff as well.
Yeah, it's super cool. Trust me, you're gonna really enjoy this thing. It's such a leap. Oh, I'm excited. I wish this was a video podcast and I could actually have done the demo the whole time through to show all the steps, because it is spectacular. So we were recording .NET Conf a couple days ago. I have a cameo at the end where I come in and I'm like, this is one of the biggest innovations that .NET's had in a couple of years. But that's what's cool about .NET is it feels like every year, every cycle, there's a new thing, and this will be a new thing that we'll get better and better at over the next couple of years. This is just the beginning. And so I should also just kind of preface that Aspire is not GA. .NET 8 is fully GA. Aspire is a workload that runs on top of .NET 8. It is in preview, and it will GA sometime, hopefully early next year. And so for folks that don't know this, workflows is a way to build a whole stack on top of .NET. So if I install like .NET 8 on my machine and I want to build a Maui app, well, there's no Maui bits by default because we didn't want to put too much stuff into core.NET. And so Aspire is actually what we call a workload. So if you ever installed Maui from a command line, you basically say .NET workload install Maui. And for this, it'll be .NET workload install Aspire, and that will go and grab all the bits. You can also do .NET workload upgrade. That'll upgrade you to whatever the newest Aspire bits are and stuff like that. So we have this mechanism to go build stacks on top of .NET without actually baking them into the actual core runtime, that was one of our design goals way back in the day.
So you mentioned about using the Aspire tool and creating this orchestration project. Is that a Visual Studio thing, or can you use like the .NET CLI to create this?
It's all .NET CLI. So obviously, if you're inside of Visual Studio, we do have a bunch of right-click gestures that will bring up some UI to help you with those things. But everything I described can be done from the command line. That was also one of the tenets of when we rebooted .NET back in 2016. Everything is command line first. If I'm on Windows machine, I've got Visual Studio, but I might be on a Mac or a Linux machine. And in that case, I'm going to be using VS Code likely, or Writer. And, you mentioned at the top of the show as well, one of the other cool things that we have recently GA'd is the C# Dev Kit. We've had an extension for VS Code for a long time, but what makes the Dev Kit different is what Dev Kit is we basically taking the engine that we have inside of Visual Studio, and we're now using that same engine to power VS Code. That's great for us as a team because we're not duplicating code. Before there was a different implementation inside of VS Code than there was inside of Visual Studio, and it means we're sharing that same implementation of our language engine across both of the platforms. There's also a Maui Dev Kit as well. And so for the first time ever, you can actually build Maui applications with Visual Studio Code as well. So C# Dev Kit gives you, generic .NET. Maui Dev Kit gives you the ability to launch, emulate Android emulators, iOS emulators, and iPad emulators and so on and stuff right from VS Code. And I'm happy to address this as well as, we announced earlier this year as well, the kind of end of life for VS for Mac. And I don't think we gave a great explanation of why. The biggest feedback we always had for Visual Studio for Mac was it's not like Visual Studio for Windows. And literally, I think it's kind of to all of us. It would be very difficult to basically clone every feature from VS for Windows and make it work in VS for Mac, because the operating systems are actually different operating systems. They work differently. And so it kind of became obvious to us over time that was a we would never get there. And so why do we focus on the thing that we can make consistent across all the operating systems, which is VS Code? And so we think it's just a better investment of our resources to go make, a Maui kit and a C# dev kit that work across all the operating systems. That said, you're still going to have the best features and the best development experience in Visual Studio for Windows on a Windows PC. That's still, and we'll never take all the features of Visual Studio for Windows and put them in VS Code. If you did, well, then they're the same product. And, I think we all believe that VS Code is the lightweight thing, and Visual Studio is the Cadillac experience with all the crazy features. And most people like myself use both.
I think it also helps with onboarding as well. If you've got like people that are maybe Angular devs or something else, and or whatever it is, Go, whatever, then if they want to like play around with .NET, being able, like they might be using VS Code already, so that's quite nice. So if you did C# in VS Code previously, you'd use like probably OmniSharp or something like that. And if you were using, so presumably this is going to replace that. If you're using other editors, like for example Vim or something like that, I know you can use OmniSharp as an LSP. With this new C# dev kit, is there any kind of LSP support for other editors as well?
We would still say use OmniSharp for those. For the other, if you're using Vim or Emacs or something like that, that's why we don't want to make the OmniSharp stuff go away. We want to keep that stuff going as well. And that's for the editors that are not a VS Code or VS Editor. I think it's beyond the scope of C# dev kit to go try to work with every editor out there on the planet. But I do want to highlight, you're right. One of the other goals of C# dev kit was exactly what you said, is if you're a new developer and you're already a Python developer or a Node developer in VS Code and you want to try .NET, we want to make sure that experience is a great experience, that you might go there first. You might decide at some point to go use the bigger VS as well, but we think you're going to start from that direction, and that's why that making that experience a very good, clean, fast experience is super good.
Yeah, definitely. And I don't want to take anything away from the people that do OmniSharp, but it's probably not as good an experience as if you're using Visual Studio or Rider or something. I've not actually played with, it's on my long list of things to play with the C# dev kit. I did see Scott Hanselman did that video that became, I think that went viral, but showing all the dev kit stuff. But yeah, it just looked cool.
I've been using it for a while. One of the things I try to do, and we kind of talked about this, before we started recording today, is I have all the devices. I have Windows PCs, I have Macs, I have Android devices, I have iOS devices. And part of the reason I do that is, in my job, I want to make sure that our developer tools for Azure and for .NET work great on all these platforms. And so I kind of move in and out of stuff. I'm actually, some days I'm on an ARM64 Windows device. Some days I'm on an x64 Windows device. Some days I'm on an ARM64, Apple device. And I'm always moving back and forth and making sure we don't have edges. I've spent a lot of time recently making sure that all of our tools work great on ARM64 machines, whether it's a Windows ARM64 machine, or we shipped a ARM64 Windows device last year called Volterra, Project Volterra. And that's because, we see ARM kind of going everywhere. And part of my job is to make sure that, Azure Developer CLI, Dapper, our VS Code extensions all work great on all the devices. And so it's multitasking between every type of device you would imagine on a regular basis now.
Oh, you've mentioned Dapper. I really want to start a conversation, but that again, Dapper and how that relates to Aspire and everything would be another episode in its own.
That's it. Once again, we should have Mads on, and we can have Paul Yuknovich on as well. Paul is the person in my organization that works on Dapper. We have great Dapper support coming for Aspire. And so for folks that don't know it, Dapper is a microservice framework. Cool thing about Dapper is cross-language, which means that you can, imagine you're in an organization that has an API written in Java, and you want to have a .NET application that wants to use that API. Dapper kind of mooshes over that. And Dapper also brings a bunch of great principles as well. So it does the distributed trace logging across the languages. So imagine your distributed tracing now shows the call going from C# to Java and back. It does the retry policy stuff as well, because, once again, we've got .NET's got the retry stuff covered with Aspire, but my Java app might not have that. And so it does that work for me and a ton of other stuff. It can actually abstract away, and you mentioned RabbitMQ earlier. Well, maybe on my local machine, I'm using RabbitMQ, but when I publish to the cloud, I'm using Service Bus. If you write to Dapper, you can swap the RabbitMQ out with a service bus without changing any of your code. But Aspire is going to have a Dapper component. So you can basically add Dapper to an Aspire application. And when that happens, we actually will boot up Dapper in a container right next to your application. We do all that logic for you. So, but that would be a great podcast as well, to have Paul come on and talk about Dapper, and have Mads come on and talk about C# 12.
That sounds awesome. Yeah, definitely. So like, you've mentioned tracing quite a few times, and you mentioned it with Dapper and you mentioned it with the Aspire stuff. And I think when you said it with the Aspire, you were talking about it when like you can F5 and you see a dashboard. When it goes into the cloud, can that hook up into OpenTelemetry? So you can have this kind of, see these traces and logs in Grafana or wherever your chosen observability platform of choices.
So our plan will be to make the same dashboard work in the cloud as well. So you can decide to go use Grafana, you could go decide to use an App Insights, but I'm kind of pre-announcing or pre-thinking. I was talking to Jeannie Lawrence. She's the developer lead that works on Azure Container Apps. And we want the Aspire dashboard to run in your production app as well. So can't say when that's going to show up. It would maybe by build of 2024. But yeah, I don't want the dashboard just to be a local thing. When you see the Aspire dashboard, you're going to want that in your production application as well. And so we're going to go do the work to do that. We'll give you our flavor of it, but you can also replace that with Grafana, App Insights, or whatever observability tech is the thing that your organization standardizes on.
That does sound pretty awesome. Now, I'm very aware that sadly you have a hard stop on the hour, which is kind of like now.
We can do a part 2. I'd love to come back and talk about, we didn't get to AOT, and we didn't get to there's a cool term we call Blazor United. We had this effort way back in 2012, and we called it One ASP.NET. And that was because back then we had built, the original ASP.NET was ASP.NET Web Forms. We had built ASP.NET MVC. We had built ASP.NET Web API. And most of our customers wanted to be able to use all 3 of those in the same application. And so the One ASP.NET of the 2012 era was doing all the right tooling goop and framework goop, so you could run a Web Forms application with a Web API inside of it, both technologies at the same time. One of the big announcements for .NET 8 is Blazor. Now you can actually return a Blazor component from an MVC view. You can return a Blazor component from a Razor page. And so now, basically, I call this the One ASP.NET V2, where suddenly, you don't have to go rewrite your MVC application to use some Blazor tech. So we're making Blazor run in all the places. And even cooler, you can make a Blazor component, and you can even let us decide. Do you want us to server render that Blazor component? Do you want us to client render that Blazor component? Do you want us to... and so there's a whole bunch of stuff in that space. But I'd love to come back and do another 30 or 40 minutes and talk about Blazor and talk about AOT.
That'd be amazing. I was actually watching a video by Dan Roth earlier today talking about all that stuff. And yeah, it looks so good, so good. But yes, I would definitely love to do a part 2, but I'm aware that you're late for your next meeting. But yeah, just with that, just a massive thank you for joining us. And this will be released at some point during .NET Conf. I'll probably have to wait till afterwards, but if you give me the nod.
After the keynote, you're good to ship this after the keynote. So that, but if you want, we could actually set up, Dan, we could set up a podcast where I actually bring Mads and Dan Roth, and we talk about all of these things we missed today. We can all get in a room in Building 18 on Microsoft campus and do it together.
That would be absolutely incredible. It really would.
So let's offline, let's go figure out how to make that happen, and let's do a part 2.